Good afternoon, everyone, and welcome to the final session of Kwame Transformer Day. Before I introduce our speakers for this afternoon, I'd quickly like to go through some general housekeeping rules for the webinar. The session will last for around 60 minutes and will feature 3 presentations, with 10 to 15 minutes reserved for a Q&A at the end of the session. You should all see a panel on the right-hand side of your screen with various tabs. If you've got a question that you'd like our speakers to answer, please use the question function in that panel throughout the session, and we will get to them during the Q&A. The chat will also be open throughout the session. Please feel free to use this and let us know if you're experiencing any technical issues. On that note, I'd now like to hand over to our moderator for today. And it's my pleasure to introduce Chris Gerber, who is the brand ambassador and advisor for power technology research. Chris is the former CEO of ETD Transformers in the Czech Republic and has worked for, and amongst others, the SGB Group, as well as CG Power Systems. In his career, he's worked for and cooperated with some of the most noticeable transformer utilities in Africa, the Middle East, and Europe, and has managerial experience working for both power utilities as well as transformer and switchgear manufacturers, which enables him to offer a unique reflection on the global transformer industry and the challenges it's currently facing. So with that, I'd like to hand over to Chris. Thank you for joining us, who will take us through the rest of the session.
Liam, thank you very much. And indeed, good afternoon to the audience. I would like to introduce our panel today, distinguished group. First of all, Ms. Merv Maiden Avishi. She is the product manager for transformers, substations, and cable accessories. She has worked for Siemens, ABB, Mercedes-Benz, Best Transformers, and is now with Eaton. She holds degrees in electrical engineering and an MSc in engineering management, and she is responsible for the formulation and implementation of the Eaton Global Product Vision and Strategy for transformers, substations, and cable accessories. In addition to that, we are fortunate enough to have Lucas Branco de Oliveira, Business Development Manager, born in Brazil. He holds pre- and postgraduate degrees in mechanical engineering and business administration and management. He joined Cargill in 2013, and he has played a significant part and role in the development of the ester dielectric fluid business in both the Americas and Europe. He is currently responsible for application and business development of Cargill ester dielectric fluids for Europe. Lastly, we have Andreas Hilgus. Andreas is the Visila sales manager responsible for business development and sales within Europe, the Middle East, and Africa. He holds a bachelor's degree in engineering and has previously worked for Royal Smith, part of the SGB Group, where he held various managerial positions in project management, after sales and services, as well as business development for power transformers. Liam, just also from my side, thank you very much to CIME in hosting this platform and indeed making this possible. CIME has always been the place to attend in Berlin, and I think I can speak on behalf of all participating and attending today, is that we are looking forward to attending the show and the exhibition in Berlin again. Having said that, let's start with today, and my introduction is as follows. In a fast-paced world where constant change has become the norm and innovation has constantly changed preconceived ideas and methods, the concept of clean energy has been catapulted into the light. The debate has shifted. It is no longer about fossil fuels and the cost of mining limited supply of black gold, the threat of nuclear energy, the seemingly endless fluctuation of the oil price, or the cost and viability of hydro energy. Renewable energy has come of age. We have become accustomed to a new horizon. Wind turbines installed on and offshore have become commonplace. Solar is about to become the buzzword of yesterday. What will the future landscape be like? What challenges and opportunities will it present? It is clear that demand for electricity will not only remain, but continue to increase. Global warming is a fact. The world has to find new ways in meeting these demands. In doing so, The future of the planet and future generations needs to be safeguarded. It is a responsibility shared by all. It need not be confrontational. While governments commit to a global reduction in emissions and create the legal framework for this, it is up to the business leaders of today to plan and strategize for the new tomorrow. Their knowledge, expertise, insight, and leadership will not only form part of, but also contribute to the new energy landscape. Our CMA PTR session of this afternoon will focus on new innovations. Therefore, please allow me to introduce our first speaker, representing Eaton. Welcome and best of luck, Merve.
Thank you very much, Chris, for introduction and also making such a great opening to our session. Hello, everybody. Chris actually made a very well introduction. My name is Merve Maydanavcı. I am the product manager of Transformer, Substation and Cable Accessories in Eaton. I am driving the global product strategy of this portfolio, working on the marketing strategy and also driving the product development. Today, with other panelists, we will talk about energy transition mainly, and in my presentation, I'll talk about powering tomorrow's grid with sustainable transformers. Then I'll briefly mention Eco-Design Directive from the European Commission. Let me start energy transition explanation with figures from our current world, because we have a spectacular growth trend called as energy transition, and it is a fact for our tomorrow's grid. The global electricity demand is increasing. We expect it to increase by 57% by 2050. And by the same year, the share of renewables in the electricity generation will reach up to 75%. And energy demand will not change this, will not create the need of energy transition. Also, system resilience will become more important than it is today. We expect its performance to be measured by shortened outage durations. As Eaton, we are all aware of the growth trend in the world, increasing energy demand of the world, and we are committed to build a sustainable planet for our future. We are dedicated to improving the quality of life and the environment by using power management technologies and services. The shift to more sustainable carbon-reduced future is accelerating, and energy transition is actually allowing all of us reaching our environmental targets. Because this energy transition is driven by the replacement programs of carbon-based fuels with renewables. So it is in the nature of energy transition, I can say. Generated energy distribution points, bidirectional energy flows, intelligent power management systems. These are the facts of our tomorrow's grid. And as Eaton, we have an everything as a grid approach to enable flexible energy systems powering the future. When we say everything as a grid, actually we are talking about a perspective in energy management while we are changing and managing this energy transition distribution. And when you say everything as a grid, you can actually visualize a future where homeowners will use their EV cars batteries as a backup power of their home during the blackouts. Or you can consider data centers operate by the renewables stored on their side. Another sample can be considered from manufacturer side. They will be reducing their operational cost by selling electricity back to the grid. So this actually, I think, explains very well the potential of intelligent power management. And this can be considered as a limitless. As Eaton, we are developing our complete portfolio by considering the future need of the grid, future need of the world. And our complete IEC assemblies portfolio, including transformers, MV, LV, switchgear, substation, and RMUs, they are all pioneering electricity sector. And we are constantly improving our products' efficiency and also their adaptability for the future grid's needs. Provide fit-for-purpose and innovative products for maintaining the grid and environmental sustainability. This is what truly matters to us. With dedication, smart thinking, innovative approach, as we always say in Eaton, we can make it work, also for energy transition. And how we are achieving this and our adaptability to energy transition. During 2019, as Eaton, we invested $606 million for our R&D activities. We supported global network from our 6 innovation centers where more than 10,000 engineers work in. And also, we target 60% of our solutions help against climate change by 2050. So we are not advocating for our customers only. We are stepping up our environmental commitment as well. By 2030, we have very strict and measurable environmental targets. We want to switch carbon neutral operations, and we want to reduce the emissions by 50%. And we want to reduce, again, also the indirect emissions by our supply chain and also from our customers' perspective. Our another target is certifying all our manufacturing plants as zero waste to landfill. On this target, we actually reached a couple of achievements already, and they are remarkable. We reduced greenhouse gas emission of all our manufacturing plants by 19%. And we have already certified 60% of our manufacturing sites as zero waste to landfill. We are supplying 12% of our energy demand through renewable sources, and we have already reduced our water consumption by 7%. As the climate change is an undeniable fact of our world, we see major commitments for net zero future. Governments have policies supporting this environmental friendliness act of the grid. For example, we can talk about the European Union recent regulation, which is published in 2014. So I want to show this as an example of a regulations because all over the world, now the governments are setting minimum efficiency levels to limit the environmental impact of electromechanical products and also increase their efficiency in the grid. And considering the long lifetime of transformers in these electromechanical products, transformer plays a critical role in overall network's efficiency. And there will be a new implementation in July 1st, 2021 in the European Union. Therefore, as a sample of this regulation, which is supporting the efficiency and environmental friendliness, I want to talk about Eco-Design Directive of European Union. This is mainly actually an efficiency guideline, which is setting minimum efficiency level for transformers. It applies to small, medium, and large power transformers. And it is in effect from 2015. And the second stage called Tier 2 will become effective July 1st this year. So we can say in a week, Tier 2 will be in our lives. I can summarize how we will see the impacts of Tier 2 implementation in our lives. This will be applicable in European economic trade area. So not only the European Union countries, but also in the UK, Liechtenstein, Norway, this efficiency will be valid and mandatory. The main purpose of this regulation is reducing the carbon footprint of the products and increasing their efficiency by guaranteeing lower loss levels. We are, as manufacturers, we, distributor, end users, we are all responsible for the compliance of the products. So let me a little bit explain the idea behind this regulation, why European Parliament decided to publish such a regulation. In 2007, the European Commission started the discussions if there can be a efficiency regulation for transformers. They started extended studies by including stakeholders such as transformer manufacturers, utilities, end users, and after their extended analysis study, they published a regulation. It is published in 2014, and it is published in official journal of the European Union. They introduced the regulation by two implementation stages, as Tier 1 and Tier 2. In Tier 1 became mandatory in 2015, and it was actually set with the idea of 2020 target of EU at that time. Renewable sources of generation 20%, energy efficiency improvement 20%, and cut greenhouse gas emission 20%. After Tier 1 implementation, the European Commission evaluated the outcomes of Tier 1 implementation. They checked if they checked the outcomes, if the implementation reached its target, if it is serving well enough to our commitments. And in 2019, they published an amendment to revise some efficiency requirements explained in the regulation and also define the transformer types. Stage 2, as also highlighted before, Stage 2 is called as Tier 2, and it will be mandatory for all transformers placed in the market starting from July 1st, 2021. We talk about European Commission's target. It is mainly increasing the efficiency, saving the energy consumption, the energy losses caused for. For you to visualize the saving we can make with this high efficient transformers, I want to use this example. By using more energy efficient transformers in the European Union, we can save approximately around 16 terawatt-hour savings annually. And this means half of Denmark's total annual electricity consumption. So we are actually saving as a half of a country's energy usage. So this is remarkable, I think. Now let's a little bit talk about what changes occurs on transformer side, because we talk about Tier 2 transformers, better performance in the grid, but what happens to transformer? Tier 2 transformers are more efficient. Their life cycle cost is lower. Their sales prices are actually higher because to lower the guaranteed loss levels, you have to use more materials in it. And of course, we end up with more expensive transformers. However, although the sales prices are higher, due to lower operational cost, the TOC of transformer is way lower than Tier 1. And the approximate payback durations can be considered around 2.5 and 3 years. And considering transformers' lifetime of 25 to 30 years, after the difference paid back in 3 years, you will be saving during the operation in the remaining 25 years. The transformers, because of the increased material inside, the dimensions get bigger, the total weight increase, and the active part gets bigger as well. And as a chain effect, the tank of the transformer gets bigger. So at the end, we are having a transformer which is heavier than Tier 1. Another good side, especially for transformer used in the commercial areas, Tier 2 transformer has lower sound levels. On the right, I prepared a very basic comparison of 2500 kVA transformer tier 1 and tier 2 options, you can see the losses has been decreased in tier 2, and efficiency is of course higher. And energy savings, we talk about operational cost. Energy saving is 275, let's say 276k kilowatt hours. And what will be the environmental impact? How we will measure it? Because we said increasing energy efficiency and also reducing environmental pollution. We should measure environmental pollution degree as well. And for environmental impact, tier 2 transformers will help us saving carbon dioxide emission by 135 tons. And how we will visualize again this 135 tons, it is equal to 12,000 trees carbon dioxide absorption. Again, the operational costs are decreasing, environmental impact cannot be deniable. So I think this is showing us the importance of the efficiency of transformers in the grid. How we should present that transformers are in compliance with the regulation? The biggest important thing, the most important part is, of course, guaranteeing the efficiency and losses, which is described in the regulation, but it is not enough. We have to supply EC declaration of conformity document, which shows the weight of all main components of transformers, information on rated power, load losses and no load losses, and other technical parameters should be available, and manufacturer's name and address. This critical information should be available with transformers. And as a conformity sign, the transformer should have CE declaration of conformity marking. We said tier 2 is becoming mandatory this year, so what will happen next? Actually, this is not very certain now, but the European Commission will evaluate the outcomes of tier 2 implementation. They will check the achieved environmental impact. They will check if energy efficiency level of the whole grid could be decreased by implementing tier 2 transformer efficiency levels. And in 2023, based on their evaluation, they may announce another level called tier 3. And this tier 3 may have stricter loss levels. The downside of decreasing the losses is increasing the material used in transformers. And to use the words resources wisely, there should be a balance between material usage and the product efficiency. So the European Commission will evaluate if tier 2 implementation is feasible or not. And if necessary, maybe on some specific transformer groups, they may revise the requirement, or they may change the overall guaranteed loss level requirements. So we all know that it will be evaluated, and there might be tier 2 level in the future. As Eaton, we are more than ready to supply tier 1 and tier 2 transformers. We have already supplied tier 1 and tier 2 transformers to European Union, but we also supply transformers which has higher efficiency levels than tier 2. We have proved design methodologies. We are using highly efficient materials in our transformers. So we are happy that as Eaton, we will be supplying high efficient transformer to our grid to help our environmental targets. As Eaton, we always say we make what matter works, and here we will make it work by evolving to meet the ever-changing needs of our world. I try to explain the energy transition growth trend in the world and how we are meeting as Eaton. And I am thinking that tier 2 implementation is a trend topic, and I'm hoping that I could explain I could explain it briefly. And I believe we will have a Q&A session at the end of our panel. So feel free to raise your questions about any topic in energy transition of transformers and the grid. I will be more than happy to respond them.
Merv, thank you very much. Your insight and knowledge is clearly visible. Thank you very much sharing your understanding of the regulatory framework and the role Eaton will be playing in meeting the environmental targets. We look forward to the question and answer session, and I have no doubt there will be some interesting questions for you in this regard. Thank you very much.
Thank you, Chris.
We now move on to our second panelist, Lucas Branco de Oliveira. Lucas, welcome. We are ready, willing and able, and we look forward to your presentation. Please proceed.
Thank you very much, Chris. Thank you for mediating today. And also would like to mention that it's an honor. Thank you for the audience and also for the organizers of the event. So I want to share some insights about the application of our technologies. So Cargill Bioindustrial is today the global leader in the supply of dielectric ester-based fluids. So we do produce natural esters and synthetic esters, and we have manufacturing plants in 6 different places globally. So we are ready to supply our technologies everywhere in the world for all the OEMs and DSOs and TSOs that would be interested in benefit from that usage. So what we are going to talk today, and I think it's aligned with what was just presented and for some sessions that happened earlier today, is that the resilience of the networks and the grids need to be even higher from the next few years because of the increase of demand of electricity. And the transformers are vital parts of the grids and networks. So your network or your grid is also as much resilient as your transformers are. So we need to be looking into ways to manage that additional demand and make and keep the networks and grids with all the quality levels and even higher levels in the future, despite the additional demands that we are going to see. So just one very short disclaimer here about the information that's going to be presented, but of course, let's go to the topic. So some of these graphs are even aligned, it might be even have been seen earlier today during the other sessions, but the message is very aligned with just heard. So we do have an increased demand of electricity from EV mobility. We also have additional demands from, for example, micro generation. So we have in many places through all the world, we see a lot of solar panels being installed and connected to the DSO networks. And of course, we even have in some specific geographies mandates to be gas-free in the next few years, meaning that even the heating systems and things like this need to be disconnected and from gas and be fully electrical equipment. So the effect that is expected with that is that the normal loading curve from the transformers that have a peak load like once a day for 30 minutes to 2 hours, it will be much different. It will look much different in the near future. So we will be seeing multiple peak hours, longer peak hours, and even flattened curves. For example, if we consider that during the day, we are going to have the solar energy generated being injected to the network, and during the evening, we are going to have the EV vehicles being loaded at home, and also the heating, or for example, during the winter being fully electrical. So this will impact directly how the transformers will respond. So their lifespan, their average lifetime will be directly affected to that, because these are also thermal machines, and how much it is subjected to thermal stress and temperature caused by those loads, it impacts directly the insulation system. So meaning paper and fluid. So currently today, we understand, all the experts understand that the transformer lifetime is really based on the life of its insulation system. We hear a lot about paper aging. We also understand that fluid is also very important. So the fluid needs to keep also its characteristics throughout the life of the transformer to make it still working properly through the 20, 30, 40 years that we expect the asset to work. So we need to be prepared for those additional loads to make the transformers still resilient and able to cope up with these additional loads, additional thermal demands. So when we talk about FR3, FR3 is a dielectric fluid, it's a natural ester, and it's really being used to as a way, as a tool to improve the thermal class of a insulation system. So it helps to improve the paper and fluid insulation system thermal class. So just to have an idea, so FR3 is not necessarily a new product. We are talking about a product that was developed and released to the market 25 years ago, but we are just seeing that increase in the interest of DSOs and TSOs to use that in their transformers to have the benefits that it brings. So it was developed by a transformer OEM that has run a lot of tests to be sure that the insulation system with cellulose and FR3 would at least be the same performance for mineral oil. But we have, and of course, the transformer OEM that has developed FR3 at that time. So FR3 is now from Cargill, but it was developed by a transformer OEM. Really presented an even better result. So we have seen in lab tests and also real transformer, distribution transformers aging tests, according to the Locke method, that a transformer that has FR3 as the insulation fluid really does present a different lifetime, and of course a different resilience level. So what we have noticed is that the transformer with FR3 was able to withstand 3.9 times more thermal and dielectric demands from that test. So this test is really designed to simulate what happens in a distribution network with ups and downs and loads and temperatures, and of course the disturbances from the network. So a stronger paper, a paper that lasts longer. So we have noticed that paper, being craft paper or thermally integrated paper, when it is impregnated with FR3, it lasts 5 to 8 times more than when the paper is impregnated in mineral oil. And it was translated in an additional life of the transformer, because a stronger and more conservated paper with higher polymerization degree, it's able to cope up with disturbances in the network, like even, for example, some electrical disturbance that could break the paper if that would be more brittle if it was impregnated with mineral oil. So here, for example, at the bottom left, we can see how it was, the results that we got in laboratory, and also on the right, on the top, we can see the difference between two transformers that were tested in parallel with the same loads and the same demands, that we can visually see that the paper is better than in mineral oil. So what we want to do, and of course, it's to promote this type of application. It's already validated by several studies, not only from Cargill, but from different universities throughout the world. And it's also recognized by IEC and IEEE standards, meaning that this benefit that we just saw, the pictures, translates to a additional thermal class for the cellulose that is impregnated in FR3, meaning that it goes, for example, if we talk about thermally impregnated craft, from the 120 degrees when it's impregnated in mineral oil, and it goes to 140 thermal class, meaning that we can explore that additional thermal capability or as additional resilience to the transformers. So it is there. It's published in those standards. You can have a look to the Annex C from IEC or B from IEEE, and you find information about that and where does that information come from, the studies that it was based. And one important note here, since we also produce synthetic esters, is that this part of the standard is applicable for natural esters. So there is still not a full validation of the same effects from synthetic esters. So let's keep that in mind also when talking about this. So also in the transformers world, we do have several projects that already benefit from that, from distribution transformers up to transformers at 400 kV levels installed in TSOs. So this is already being used by different OEMs and different utilities to really bring additional resilience, additional safety and performance to their transformers, to being prepared for the future that they are already noticing that is getting closer and closer. So the thermal class of an insulation system that uses FR3 and thermally upgraded craft is 140 degrees. This makes that the failure mode that will bring the transformer to its end of life, it's not anymore the insulation system. Most likely another component of the transformer would be the first one to fail if we consider those benefits. So that's the idea on how to mitigate what we see as the failure mode that brings the transformer to its end of life. So this is really bringing this additional resilience in case we have multiple peak loads or flattened curves to the higher side of the transformer loading capacity. So this is a way to bring additional resilience to that. So I know that DSOs and TSOs are already planning towards that, using a lot of different technologies to be able to cope with that. But if they adopt FR3 fluid, for example, as part of their insulation system and still keep the same solid insulation, they will directly benefit from this additional thermal class and this additional resilience. So what should we expect from the transformers that use FR3, right? So we should expect a reduction in failure rate. Is this from the early failure rate or later failure rate? So for example, we see in Americas, in other geographies where the transformers in distribution networks, they have an average lifetime of 15 years, in some cases even less. So there's already something to gain with the current situation. So we also expect that these averages will be impacted by the additional load that we are forecasting. So increasing the average time to failure, for sure. We do have an improvement on the downtime of transformers and consequently improvement in the SAIDI and SAIFI indicators from the DSOs and TSOs. On top of that, and we have not really even mentioned much about it in this presentation, there are also benefits on fire safety. We are talking about a fluid with 0 records of fire in the last 25 years and adding up to about 3 million transformers installed globally and 0 occurrences of fire. So these will come even as a bonus on if you start using FR3 because of the additional resilience. It's FM approved, UL listed, so we have all the documentation that helps you with your fire safety projects. And besides that, we are talking about a natural ester. It's not fossil based. It's considerably lower carbon footprint than mineral oil. That's the traditional solution in the transformers world. We are talking about readily and ultimately biodegradable, non-toxic, and it could also be reused, right? It can be used also still as a dielectric fluid or even recycled to other applications at the end of its lifetime. So it's completely aligned with the circular economy concepts that we are seeing affecting the DSOs and TSOs, and will be even more affecting these companies in the near future. So it's completely in line with what we see both in the resilience that is required for the grids and networks in the really short term, and also with all the sustainability and circular economy initiatives that we are also hearing in the market from multiple DSOs and TSOs, not only in Europe, but also in other geographies throughout the world. So a good example of this, it's also from the colleagues from Eaton that have just presented. So they have already a specific product line that explores this additional thermal class of the insulation system with FR3. So they do explore that. They can handle additional capacity without damaging or aging the insulation system in case it's necessary. So this is an additional toolbox for the OEMs that want to develop specific product lines on that. And this is also, of course, additional tool in the toolbox for the DSOs and TSOs that will need it. So one quote that I consider quite aligned with our topic today. So we need to be prepared. We need to prepare, and of course, this is not the only tool that is available to do that, to get all the networks and grids prepared, but it's surely one that is available, and it's easy. It's pretty much just by replacing the fluid from mineral oil to FR3, you will get the 20 degrees addition on thermal class, and this will be translated directly to your the lifetime of your asset. So this is really something that must be considered by the industry to also be prepared for this new wave of demand. So to summarize, as a summary, if your transformers use FR3, they will be safer, they will be more sustainable, they will be more reliable, and therefore more resilient. So I hope this brought some additional knowledge for everyone watching, and feel free to reach me out in case you need any additional information.
Lucas, thank you very much. Very insightful. And I love the concept of a resilient FR3 transformer. Indeed, the transformer industry has grown substantially and has changed substantially since the first transformer was produced by Gans in Hungary in 1884. And it is clearly demonstrated by both yourself, your presentation, and also that of Merv, that the innovation is in fact showing substantial results. Thank you very much. No doubt there will be some questions for you at the end of the next session. And this brings us to the session of Andreas Hilgus and Wisela. Andreas, thank you very much. We are keen to learn what you can add to the previous panelists. Take it away.
Yeah, Chris, thank you very much for your kind introduction and also Power Technology Research for this opportunity to take part in this panel discussion. Hello, everybody. Happy to have you online. And yeah, as said, my name is Andreas Hilgus. I'm working for Wisela as sales manager for the new markets. And today's topic will be maintenance-free online DJA monitoring. But before telling you more about that and the development process for this, I would like to tell you something more about Wisela and also about innovation. So let's get started with that. Observations for a better world. That's what Wisela provides, and that's what Wisela is all about. Wisela is a global leader in weather, environmental, and industrial measurements. And right now, as we know, our world faces pressing social and environmental challenges like climate change, resource efficiency, and circular economy. And now it's more important than ever to base our decisions on accurate and reliable data. Let's tell you something more about when the story of Wisela started. So Wisela was founded by Vilo Wisela in the 30s of the last century. And basic for Wisela was that he found a Russian radio sound, and he admired the idea to use radio technology to retrieve observation results, observation results for weather forecasting, like temperature, humidity, and pressure. But he was an innovator at heart and decided to improve this concept by himself. So since that time, innovation is really in our DNA. So when we take a look at Wisela, Wisela is divided into business areas. On the one side, we have the weather and environment measurements, and on the other side, we have the industrial measurements. What we want to provide reliable and accurate and innovative products and solutions to help our customers to find answers and make smarter decisions and remove jobs. When we look at our main markets, for weather and environment, we talk about meteorology, aviation, ground transportation, maritime, automotive, etc. Having a look at industrial measurements, our main markets are demanding humidity and carbon dioxide measurements, liquid concentration measurements, continuous monitoring, and power transformer condition monitoring. You can find all our products all over the world, in the Sahara, but also on the Antarctic and even on Mars. So what we see here is the Perseverance rover, which started his traveling to Mars around about 1 year ago. And he started his mission at the beginning of this year. And he is equipped with Wisela technique, and that's our humidity sensor, HumiCap, and our pressure sensor, BioCap. Let's talk a little bit more about innovation and Vaisala. So, science-based innovations are the core of Vaisala, and this requires long-term commitment and investments in research and development. So, as you can see here on the pictures, our recently opened R&D center, which was one of the major investments of the past years. To provide you some numbers regarding innovations and the Innovation Center. So our new Innovation Center consists almost about 40 custom-made laboratories. We talk about EMC laboratory, a rain tower, vibration and freeflow laboratory, cold rooms, environmental chambers. Some more numbers about that. So in 2020, Vaisala invested 40% of its net sales into research and development. And at Vaisala, we are almost 2,000 colleagues worldwide, and almost 25% work in R&D. So that's roughly 500 persons of us that work in R&D. Giving you a quick overview about Vaisala power and also some substation offering. So we do not only have products to do online DJA monitoring, but there are also some other areas which we can provide to you. For example, our weather stations for dynamic line ratings, or our global network lightning detection, which detects lightnings all over the world, and which can be utilized, for example, by utility companies. Today, as we heard also from Merve and Lucas, the trend of urbanization drives people together in cities which require flawless and ongoing electricity distribution. Also, the key industrial hubs in society, such as hospitals and manufacturing facilities, consume electricity to ensure safe operation. We as Vaisala, we provide measurement solutions which make the maintenance and control of power transformers smooth and predictable. Continuous transformer condition monitoring supports smart grids, where electricity consumption is controlled and balanced as needed. Reliable and continuous online monitoring enables the transition from reactive to proactive maintenance, so that potential faults can be detected in time and thus avoid power outages that threaten society and safety. The growing need for electricity is supported with an extending transmission and distribution network, supported by a growing number of power transformers. New transformers are more and more equipped with monitoring equipment. Also, when transformers generations grow old, they require more online monitoring to secure their long lifespan. So we provide maintenance-free DJA online monitoring for old and for new transformers. But how did that development process look like? I think at Vaisala we had a good foundation when we entered the market of DJA online monitoring. We had our known technology for measuring moisture in oil, our HumiCap technology. We have our CarboCap technology, our optical measurement for measuring gases. And we have a lot of experience with developing components which have to survive in harsh environments from our weather business. But if you want to do something really different in the area of D&J, it's important to know what are the customer experiences. So one thing we did is we listened to the voices of the market when designing our product. So as you can see, we got some feedback regarding what end customers were not happy about. For example, existing devices required too much maintenance. There are consumables which are needed, and stability of results. So what we wanted to do at Vaisala, we wanted to change this. So what we did is we linked our customer relation experience from sales and marketing and business development to our R&D department. And the goal was finally to meet the requirements of our customers. So when you look at our solutions, we have no more consumables, no calibration gas, no carrier gas. We can measure hydrogen and moisture in oil direct in oil. No membrane technique is necessary. So with all these things, we finally came to our product, our first maintenance-free online DJA monitor, the OPT 100. So our OPT 100 is a safe and reliable maintenance-free online DJA monitor, which is measuring all the 7 defined fault gases by Seagrade. And this enables you to do complete fault diagnostics and to identify all the 10 defined faults in an early stage. This is done by using Vaisala patented optical infrared measurement technology, which is manufactured in our own Vaisala clean rooms. There's no need for calibration due to our unique auto-calibration function. We do not suffer from cross-sensitivity because of spectral scanning, which provides selective gas measurement. There's a hermetically sealed structure, no oil leaks. The OPT tolerates vacuum and overpressure. These are some of the features which make the OPT unique. And I hope that I could give you a glimpse on what Vaisala is about and also innovation and maintenance-free monitoring device. So for more information, please check our website and reach out by me by using our contact page. And yes, now thank you very much, and please also feel free to ask questions.
Andreas, thank you very much. Your experience and knowledge accumulated whilst at being at SGB Smith and your experience in power transformers are clearly visible in terms of the condition monitoring of the transformers. Thank you for a very for a clear and precise presentation. Ladies and gentlemen, we will now proceed to the second part of this afternoon's program, in which we will in fact allow you to post questions to the panel, and they would gladly answer these. Over and above that, in an agreement with Liam from Simware, there is also the possibility to in fact publish and revert on some of the questions should we have insufficient time. So in terms of that, some of the first questions which we have received addressed to Murph and Ethan, and if I may in fact start off with this, Murph, if you are ready for them. The first question which I have is, when can I last place an order for a current standard tier 1 order and transformer?
Actually, the regulation defines the delivery time of transformer as the critical date of it as a deadline of tier 2. So not the ordering time, but the delivery time of transformer is critical. So all transformers make available in the service after July 1st, 2021 must be tier 2 transformers. You can, for example, tomorrow place an order for tier 1 transformers if it will be delivered in 3 days, which is probably not possible unless it is in the stock. So as I said, not the ordering date, but delivery date of transformer is playing a role on deadline.
Thank you very much. If I can pose a second question to Lucas. Lucas, one of the questions that was raised this afternoon, how does FR3 differ from Midel oil?
So these are different products, right? In this case, we would need to know which of the products are being referred to, because there's a range of products on the other side. So there are products that are similar, there are products that are quite different. So we would need a bit more background on that question.
Mark, this question came from Mark Holtman. Mark, if you could add, we could always try and come back to this. Thank you very much for this, Lucas. Andreas, then in terms of you,
Yes, please.
one of the questions that had been raised is in terms of your products, the final decision, the cost of operations. How do you deal with this? How do you quantify this? Who takes the responsibility for this? Please share with us.
Yeah, thanks for your question, Chris. Okay, I think you should start with the beginning. If you want to start monitoring, there's a decision that you want to make to implement monitoring. But what does it implement? There's always a technical and a commercial part. And when you have made the decision to go for online monitoring, it is important, okay, what do I want to achieve with monitoring is the first question you should ask yourself. And the second question is, what is needed to achieve the company goals when you start implementing monitoring systems? And as you are the end customer, you are the one who's responsible that the lights stay on. And that means you should make clear that you are in the driver's seat and do not leave the decisions for a monitoring system to other parties, for example, OEMs. So, and the experience we have is that everything starts with a technical specification that should be compiled with data sheets and filled in by suppliers. And like you do an evaluation process with your transformer, it should be also be done with your monitoring system. And when you think about technical items to be considered in your technical specifications are sampling and sampling preparation, moving parts, consumables, housing, expected lifetime, warranty, but also communication and data and installation. So that's the technical part. If we come now to the commercial part, you should take a little bit broader look at it, not only on the investment you need, but also on the operational cost. So what is useful to apply is the method of total cost of ownership. So ask the supplier for information about that. Yeah, and are spare parts needed, for example? What calibration requirements does the device have? Are there software fees which apply, or software licenses, consumables, so that you can make the calculation by yourself? So that's and finally come to a decision which suits you to achieve your goals you defined by implementing monitoring systems.
Andreas, thank you very much. Very comprehensive. If we can move back to Eaton again, Merv, are all types of transformers affected by the directive?
Mm-hmm. It covers small, medium, and large power transformers. However, the regulation is not mandatory, is not defined for special application transformers. They are the full list of exception is available in the complete regulation, but I can name the mostly used ones in the network. For example, traction transformers, earthing transformers, or the ones used in offshore applications. The mandatory loss levels are not applicable to these unique transformers.
Thank you very much for that. The next question addressed to Lucas. Lucas,
Yes.
what does the experience of utilities using FR3 fluid in their transformers demonstrate?
Sure, good question. So in this case, we have been working with different utilities globally for the past 15 years at least. So the utilities that have made early adoptions of FR3 as their standard fluid for their transformers have already presented and shared with us some information about the decrease in failure rates on those transformers when compared to the transformers that were previously used in mineral oil. So there is already field data that really backs up this statement that the transformers, just by using FR3 as part of the insulation system, still using cellulose, solid insulation, really present that behavior that we have noticed in laboratory and also when aging the transformers by the locking method. So this is really what the DSOs are sharing with us. So we're already a visible decrease in failure rates and an increase in average asset lifetime.
Lucas, thank you very much. A question for Andreas. Andreas, why are you not measuring O2 and N2?
Interesting question, Chris. Thank you very much. If you take a look at the gases which are measured or can be measured, it's always you should measure which gives you value information. And O2 and N2 are indicators for air leakages in the transformers. Both gases do not belong to the 7 defined fault gases to do full fault diagnostics with the 10 defined faults. So, and when you want to measure O2 and N2, this requires maintenance, and that's something we don't want to have within our product. But that's now where, Vaisala's innovation capability comes around the corner. To detect air leakages, we introduced the functionality or the method of total gas pressure. And what does this mean? So that means our OPT uses partial vacuum extraction to extract the gases from the oil. And our system also includes a pressure sensor, which makes it possible to determine the air leaks by measuring the total gas pressure. And the total gas pressure is the sum of the partial pressures of all gases which are dissolved in the oil. And in case of an air leak into the transformer tank, the largest portion of the gases would be nitrogen and oxygen. And both can be completely extracted from the oil because of their poor solubility. Proportion of fault gases in the total pressures value are negligible. And even if all oxygen would have been consumed, the pressure value would give a reliable indication of a leak. So leak can be identified with this way because the nitrogen value will both dominate and increase over time as it is neither formed nor consumed in the transformer.
Andreas, thank you very much. Murph, another question for you at Eaton. Are manufacturers allowed to produce transformers with lower efficiency than that required in the EU regulation?
The efficiency levels are calculated by the loss levels, and regulation says fixed losses up to 3,150 kVA, and afterwards peak efficiency index is described. And based on the rated power, the transformer must meet that minimum efficiency level, either by following the defined peak efficiency index or the fixed losses in the regulation. However, any of the manufacturer is not allowed to manufacture transformers to be used in the EU, of course, which it has lower efficiency. However, the other way is possible. We can make more efficient transformers, of course. It doesn't be identical, same as described in regulation. We can always supply transformers with better efficiency levels, but lower is not possible.
Okay, thank you very much for that. Lucas, a rather interesting question this afternoon. What are the financial implications and benefits expected from the adoption of FR3 fluid transformers?
Perfect. So the FR3 field transformers, right, ester field transformers, they do have a higher cost than regular mineral oil field transformers. There is a difference in cost in the fluids, right, that impacts the cost of the final product. The difference that we see in different markets is not that big when we compare transformer to transformer. So it's a few percent. So it's not like the double of the price of the transformer. So what we see is that this additional investment that is made by the DSO or the TSO or the customer that wants a FR3 field transformer, it brings back a payback in a relatively short time. So this additional lifetime of the transformer or the postponement of the need of a new transformer to replace that one that's being taken out, or a second transformer to cope up with an additional load, really pays this investment, this initial investment, relatively fast. So we do have projects with the DSOs that presented interesting payback and interest in return of the investments. So this can be, we can give the support for the DSOs and DSOs that could be interested on that, because we do have experience on how to evaluate that in advance to an introduction or adoption of FR3 transformers.
Lucas, thank you very much. Another question for Andreas. Andreas, what are the key benefits of your Optimus 100?
Yes, key benefits. Also a nice question. When I would put it into three headlines, it works in the harshest environments. It's intelligent and hassle-free, and it's a peace of mind. Why I'm saying that? So works in the harshest environments. I think I explained already that we are coming from weather business, and all our weather stations are located in the harshest environments. Yeah. For the OPT, we use stainless pipes. It's IP66 rated housing, temperature controlled gas and oil handling, magnetic pump involved. And we have no consumables, which are necessary to service or to replace. Talking about intelligent and hassle-free, we have an integrated web user interface, and for that, no additional software is needed. Yeah, and it can be quick installed. You just need to contact the oil pipes, power it up, and connect it to the web user interface, and that's all you have to do. And in cases of a power outage, our system has a self-diagnostic and self-recovery function. And peace of mind, what we do not want to have in the control is false alarms. And what I also already mentioned is the unique auto-calibration ensures our long-term stable online measurement, and there is no recalibration needed in the factory again.
Andreas, thank you very much. A question for Lucas, if I may change the order a little bit. One published this afternoon, the combination of FR3 with higher temperature materials like Nomex could yield in potential smaller and more powerful transformers. Could this be a good solution for the offshore wind industry?
Yes. This combination really brings additional benefits, because when we talk about using the Nomex, for example, as a high thermal class solid insulation material, the application it's limited by the thermal class of mineral oil alone. So mineral oil, if you increase the temperature too much, it starts to get dark and it starts to lose its dielectric properties. So FR3, when directly compared to mineral oil, has a much higher thermal class. So the same standards that we have presented this afternoon, talking about cellulose materials, also give additional benefits for the insulation system that uses Nomex and also FR3. So you can even explore additional thermal benefits if you do this combination. So yes, it's an important solution also for offshore and wind, also, for example, for mobile substations, or all the transformers that need to fit a space that's very restricted, something that we might even see now with the tier 2 transformers that need to fit the same substations that were tier 1. So yes, it's correct, this information.
Lucas, thank you very much. A rather interesting question for Ethan. Can new and better high-efficiency materials, like, for example, core steel, reduce and even eliminate the bigger size and weight of Tier 2 and perhaps Tier 3 transformers? And could amorphous core become a standard if efficiency requirements will increase? Your thoughts on this?
This is another good question, I should say. My answer to this question is partially yes. The way of increasing transformer efficiency, lowering guaranteed low loss levels. There can be two ways of doing this, mainly using highly efficient materials and decreasing core density or current density in the core and in the windings. These two methods provide us lower loss levels. And if we use higher efficient materials in the core, this will reduce the core, this will reduce the no load losses of transformer. However, the current core steel supply, the current performance of even the best core steel in the market doesn't allow our transformers to be in the same size. And this is valid for grain-oriented core steel, not for the amorphous steel. But for tier 2, using amorphous cores is not needed. And for tier 3, I believe the European Commission will evaluate this topic as well, because this will be another manufacturing technology of amorphous core. So therefore, I expect the core steel manufacturers to promote a new steel with better efficiency, and European Commission to consider amorphous core's operational challenges, negative impacts on the operational costs. And I believe this won't be needed, even in tier 3 level. But it will be, of course, based on the decision of committee, how much they will lower the losses. Then maybe for small rated power distribution transformers, we may need to use amorphous core, but the trend seems like stacked core technology will be adequate to increase the efficiency.
Merv, thank you very much. Andreas, a question for you, perhaps the last one. Is there any documents you can recommend regarding DGA monitoring systems that could help or assist the end users and transformer manufacturers?
Yes, of course. And I can tell you there is documentation I would to recommend to familiarize with. And there was a working group within the CIDRE, and they recently published the technical brochure. The name is DGA Monitoring Systems, and it's the number TB783. And actually, convener of this group was Mr. Duval. I think a lot of us know Mr. Duval from the Triangles. And one of the members was a colleague of mine, Senja Levo, who did also provide and had an active part in this working group.
All right. Thank you very much. We are a little bit over time, so we would in fact try and limit the questions to perhaps one or two more. A question again for Lucas, perhaps to follow on with the previous question. The middle is a 7131 cooling fluid. Does that compare to the FR3?
In fact, these are very different technologies. So we do have E360, EnviroTem 360 is our synthetic ester that would equivalent to the product that was mentioned. So these are actually synthetic esters, while FR3 is a natural ester. So our different technologies, different formulations, different behaviors. So in this case, everything that we have presented today is applicable and validated for FR3 and not to synthetic esters. We have seen the table from the standards mentioning that this is valid for the insulations considering cellulose and natural esters. So it's these are cooling fluids, but the benefits are expected are different. So everything we presented today would not be applicable for synthetic esters.
All right. Thank you very much. A last question, perhaps to Merv. will there be tier 3 level implementation in the future?
This will be based on European Committee's evaluation. They will check if tier 2 transformers in the grid are helping the world, are helping the European grid reaching their saving targets by operational cost, by decreasing the environmental pollution. And they will check if lowering the losses is feasible from material usage perspective. And they may actually publish another implementation stage called as tier 3, or they may make some revisions on the current tier 2. So this will be all based on committee's evaluation. And we will know this probably by 2023.
All right. Mert, thank you very much. Liam, with your approval, you have been kind enough to allow us to continue for another 15 minutes. I would like to wrap this up. Thank all who participated our panel, but also PTR who made this possible in conjunction with Coil Winding, to thank you all for this, and look forward to the next opportunity. Thank you very much.
Thank you, Chris. And I'll just come in to say a final few words from the Coil Winding show here. So firstly, just thank you so much again to all of our speakers for a series of great presentations this afternoon and for answering all of your questions. And also to you, Chris, for being a brilliant moderator and making sure that everything ran smoothly throughout. Thank you also to all of the audience that's tuned in for your engagement today, whether you've only joined us for this session or you've been with us throughout the day. We hope that it's been insightful for you all. Just to make a note that the full webinar recording for this session, as well as the 2 other sessions from earlier in the day, will be made available on the Kwame website later this week, where you can also find all of our other webinars from the past year, as well as our newsletter and other exclusive market reports and articles. We'll also, as I think Chris mentioned earlier, pull together all the questions from this session and publish them alongside the recording, where the speakers may be able to add some more detail to their answers for you. Our white paper, in collaboration with PTR, Power Technology Research, covering transformer market and component developments, will also be releasing next week, so look out for this in your inbox. And in case any of you are confused, that is the white paper that was being sort of teased and intro to you this morning in our 9 a.m. session. So finally, thank you all again for joining Kwame Transformer Day. We hope to see you for our future webinars, and thanks again to our panelists this afternoon as well. I hope everyone has a great day.
Thank you very much, everybody.
Thank you very much, and goodbye.
Thank you, everyone.
Thank you for the opportunity. Bye.
Have a nice day. Bye-bye.